The following introduces the application in the hydrology. In nature, the circulation of water has its rules, and the water on the ground has its path to flow. The range of flowing makes the catchment region here. The catchment region is usually taken as the unit of the activity of water. The application of catchment region is like soil and water conservation and water pollution control. When the rain falls down, in the beginning, water seeps from the soil pores, and the excess water will be extended with the terrain height to flow. The actual water first will stay in the mountains in a small depression. With the increasing of water, the water will overflow depressions, flat to the surrounding. Outflow of water will form small streams. These small streams will gradually flow together to a location. The location is called confluence, and the catchment region is the area of these small streams together. Next, take a look at this picture. Terrain slope and aspect, the surface distribution of plants, soil structure formation, all will affect water flows and the formation of a river. These factors are involved in the distribution and characteristics of space. The values, like this, can be turned into different types of geographic information. For example, ground-based slope and aspect can be regarded as a geographic information in the data collection, also called a layer. This is a layer. Through the integration of the different layers in a system, you can make some analysis and application of this. Basic applications include water flow path connection, the establishment of catchment regions, and searching. Through the geographical information system, user makes analysis of the terrain data and get the result quickly. The information after analysis can be applied into the design of reservoir location, analysis of flood area, and so on. The following shows the algorithm of building of catchment region. First, get the height value in some region. Record the value in the grid matrix in a constant size. By the difference of height, separate which way the water flows in. Each grid has 8 ways of direction. 1, 2, 3, 4, 5, 6, 7, and 8. At this time, only the affection of terrain is considered. For example, an area with 100 square meters is divided into 5 multiplying by 5 grid matrix. Each grid stores the height value of the position. By the height value, the water will be judged which way to go in. Since the water flows from high place to lower place, and our system says the water to go in one way, the direction will point to the lowest position. Each grid can be seen as one node in a tree. The direction of flow can be seen as the connection line between two nodes. The blue star can be seen as the root of the tree. The green circle can be seen as the leaf of the tree, and the red line is the connection line of the tree. Here, the connection line in the tree is the path of water flow. The root of the tree is the conference. In this figure, the blue star here and here is the root, also meant the conference. The green area here or the yellow area are the two catchment regions. The following shows the path of water flow. The following shows some application examples. This page shows the automatic generation of catchment region and some other vector queries. The generation of catchment region can be understood from the right side animation. First, draw a river. Set some selected positions and set a conference position. Then, the system will calculate and calculate a whole catchment region automatically. Besides, the system shows some environmental vector queries like the area and circumference of catchment region in the left figure. Although, before query, the related data of this region must be collected. The following are a series of results of application about catchment region. The system not only can show the distribution of catchment areas, but also can show the distribution of a river catchment. After some settings, the system will show the river not meets the settings of user. Furthermore, the system is allowed to be set only showing the segmental river. The black region shown in the figure is the upstream region from the green point, and the red line is the river in this region. Concerning to the setting of catchment region, users can set the green number, average water depth, and minimum water area. Theoretically, any small depression can be called a catchment area. However, in most people's point of view, small depressions with shallow depths and too little water inside are not thought as a catchment region. Therefore, as the average water depth or amount of water is higher than some threshold value, the region can be thought as a catchment region. The figure introduces the minimal ratio of a region and minimal ratio of conference. The minimal ratio means the region will be ignored when the value of region is less than the value after calculation with the ratio. This is described in algorithm path of water flow above. For example, if the grid matrix is 100 multiplied by 100, there are 10,000 grids. The highest value is 10,000. If user said the ratio is 5%, the threshold value after calculation is 500, which is equal to the result of 10,000 multiplying by 5%. Then the region less than 500 will be ignored. The result after ignoring will show the path of water flow that meets the demanding of user best. This figure shows a region where the overall distribution of catchment areas and waterways distribution. Coverage of each catchment area will be marked also. Here, here, and here. By this integrated analysis, user can do integrated programming on this region.